Hi, today we're going to talk about what is type 1 error really and what is its probability. These notions are common in statistics and there's a little bit of confusion surrounding them, so I want to clear that up today. All right, so in statistics we talk about experiments. Experiments have a null hypothesis and an alternative hypothesis. Relative to these hypotheses, any experiment can have 4 possible outcomes. All right, well, let's get specific here and talk about a particular example. Suppose we're testing patients for malaria via rapid diagnostic testing, RDT. This is a common malaria test that's convenient and is used in the field in many places. So this patient test can be called an experiment. Now, in this case, the null hypothesis would be that the patient doesn't have malaria. And the alternative hypothesis would be that the patient does have malaria. So every time we test a patient, we're conducting an experiment. Now, each experiment can have 4 possible outcomes, as we set up here, 4 possible outcomes. What are the outcomes? Well, first outcome is that the patient doesn't have malaria, and RDT says the patient doesn't have malaria. So RDT has successfully cleared the patient of malaria. The second possible outcome is that the patient doesn't have malaria and RDT says the patient has malaria. Now this happens sometimes because RDT is not a perfect test. The third possible outcome is that the patient has malaria and RDT says no malaria. This is bad, because then the patient would go untreated. So again, RDT is not perfect, so this is going to happen sometimes. And then finally, the patient has malaria, RDT says the patient has malaria. This is also a good outcome. We want RDT to detect malaria. Now these 4 outcomes all have names. Or I should say, 2 of them have well-known names. Now in this case, the patient doesn't have malaria. That means H0 is true, right? So in this case, H0 is true. And also, RDT says no malaria, so this says H0 is found. So this is a correct result. So we'll just call this correct. Okay, so it's really true that H0 is the case, and the test has found that H0 is true. So the test has functioned properly, we'll call this correct. Now in this case we have H0 is true. And then here it says, here H0 has been rejected. Okay. This is called a type 1 error. Okay. A false rejection of the null hypothesis. The null hypothesis is in fact true because the patient doesn't have malaria, but the test has said the patient has malaria. That's a type 1 error. Now here we have the patient has malaria. This is H0 is not true, so H0 is not true. But the test says that H0 is true. So not H0 is found. Okay, so this is also an error. This is called a type 2 error. And in this case, the patient has malaria, that's H0 is not true. And the patient says has malaria, so here H0 is not true. And H0 is found not true. Okay, so again, this is a correct result. Right, so take a moment to take in this slide. We've talked about experiment, we've talked about hypothesis, and null hypothesis, alternative hypothesis, and these 4 alternatives. 2 alternatives are correct. If the test functions correctly, then it can either it can define that H0 is true and correctly identify that. It can find that H0 is not true and the patient has malaria and correctly identify that. Or there are 2 types of errors. There's type 1 error, which is a false rejection of the null hypothesis. And there's type 2 error, which is missed detection of the alternative hypothesis. So we're going to focus on these two types of errors. Actually, we're going to focus specifically on type 1 error. All right then. So let's make a table of the 4 outcomes and their probabilities. So the 4 outcomes can be put in a 2-by-2 table because we have 2 actual situations, H0 can be true or false. We have 2 findings that are possible from the test. The RDT test can either find that H0 is true or H0 is false. All right, so let's take some example. All right, let's suppose that we test 1,000 patients. All right, and suppose that out of that test we find that 700 patients actually don't have malaria and RDT clears them. But let's suppose that 60 patients don't have malaria, but RDT says they do. All right. Let's suppose also that 40 patients have malaria, so H0 is false, but they're found not to have malaria. So of course that's the worst alternative. And then suppose RDT finds 200 patients that actually do not have malaria, H0 is false, so they do not have, that do have malaria because H0 is false. And RDT has successfully detected that they do have malaria. So just to clarify this, this means they have malaria. And then this one says, this one is that they're healthy. It's a little confusing that H0 false means malaria, and H0 true means healthy. So just keep that in mind. H0 true is healthy, H0 false means malaria. Okay, so we have 4 possible outcomes. Now you might ask, how do we know that the RDT has given the wrong result? Well, there's another test that's even more accurate than RDT that you can follow up on. RDT is more convenient and cheaper. This other test is more expensive, so that's why RDT is often used in the field. Right? So we've tested 1,000 patients, and this is our result. Most of the time, the patient doesn't have malaria and RDT clears them. Sometimes the patient has malaria and RDT finds it out, but sometimes RDT makes a mistake. So this 60 is actually type 1 error, right? Type 1 error is the false rejection of a null hypothesis. And this 40 gives me my type 2 error. So out of 1,000 total trials, I have 60 type 1 errors. Out of 1,000 total trials, I have 40 type 2 errors. All right, so let's use this trial to estimate the error, the probabilities. I shouldn't say error, sorry, this shouldn't say error, this should say probabilities. The probabilities of the 4 possible outcomes. Right? Now, when you do an experiment like this and you estimate probability, you take the ratio, you take the proportion. So out of 1,000, we had 700 where H0 was true and H1 was found, so that's 700 out of 1,000, which is 0.7 or 70%. Okay? Now, the probability of type 1 error, that's the actual is healthy but is found to have malaria. Well, that was 60. 60 out of 1,000. And that's equal to 0.06 or 6%. Okay. Now, probability of type 2 error is going to be 40 over 1,000. Equals 0.04 or 4%. And the probability that H0 is not true and H0 is not found, which is a correct option, is 200 over 1,000. which is equal to 20%. So you can see that 90% of the time the test gives a correct result, 6% of the time type 1 error, 4% of the time type 2 error. So we conclude from these trials where we conduct this test multiple times, we conclude that the probability of type 1 error is equal to 0.06 or 6%. Okay. All right. Now, this is all my conclusion. My question is this really true? Okay, so the probability of type 1 error is called a significance level. And let's recap our calculation. It's not wanting to change for me. There we go. Let's put in our numbers. If you remember, here we had 700, 60, 200 here, and 40. Alright, so remember, we found this was type 1 error. Alright, and we found probability of type 1 error as, remember, we took 60 times type 1 error happened out of 1,000 total experiments, which is 6%. Alright? It turns out that this is not the significance level. The significance level is more like 8.6%. Why is it different? We were very careful about our calculation. Is it because the experiment was not typical? And the answer is no. The answer is, when you compute the significance level, you only consider the cases where the null hypothesis is true. You don't consider the entire table, you only consider the first row. Okay. So the calculation is, I have to take 60, it's not out of 1,000, but it's 60 out of 60 plus 700, or 760. And that's what gives me 8.6%. Okay. Right? Now, so why is this true? Why do we only divide by the first row? Well, statisticians think of type 1 error as a conditional event. They only talk about type 1 error when H0 is true. So they don't consider all 4 possibilities, only the first 2 possibilities. Alright? However, in common usage, type 1 error is treated as an unconditional event, as we have. So in common usage, in textbooks or on the internet, where they talk about statistics, they'll refer to type 1 error and the 4 alternatives that we have. So here we have 2 very different ideas about type 1 error. So which one is true? In fact, in the original paper by Neyman and Pearson, who were statisticians, type 1 error is defined as the unconditional event. Apparently, statisticians don't know this. They've decided on a different definition of type 1 error, and they've forgotten the original definition. So you've got these 2 definitions of type 1 error running around at the same time. And which one is right? Well, nobody knows, because there's no consensus. Now, if you think of type 1 error as an unconditional event, as we have, then the significance level should be defined as follows. It should be defined as the probability of type 1 error given that H0 is true. When you say given that H0 is true, that means you're only allowing the first row in the table. Right? So that's very clear. Now, in shorthand notation, statisticians use this notation: probability of type 1 error given H0. Okay? So again, if we use our definition or our common notion of type 1 error, then the significance level should be defined this way: probability of type 1 error given that H0 is true. Well, if you go to statistics textbooks and many statistics lectures, they won't say that. They'll say alpha is the probability of type 1 error, because they're thinking of type 1 error as this conditional event. Alright, so let's summarize. What is the real definition of type 1 error? Who knows? There's no consensus. Who's going to say which is the right definition? So, be careful when talking about type 1 error. You better be clear about which type 1 error you mean. These errors, so if you're not clear about that, you quite easily can make the kind of mistake that we made earlier. We found alpha is 6% when in fact alpha is 8.6%. It's not just students make these errors, professors make these errors. You can try this with your professor, see if they can catch the error. So you can always go back to the table to make things clear. All right, so that's where we are. All right, thanks for listening.